Hello, my name is Marcus Gardner, and in this small video, I'm going to show you how I am training AMC students to do 4 different problems. Now, this is for the AMC 8. I also help students with the AMC 10, as well as Kangaroo Math and MathCon. All right, in our first problem here, it says, how many 2-digit numbers have digits whose sum is a perfect square? So we need to break this up into small pieces. First, let's say part A, we need to find out what numbers we are talking about. Well, it's 2-digit numbers. So that means we're going to go from 10 to 99. Okay, now the second part is the sum of the digits. Well, the sum of the digits will go from 1 being 10, 1 plus 0, up to 18. We cannot get larger than 18. So 1 to 18. The third part is a perfect square. So we need to find all the perfect squares between 1 and 18. Well, what are they? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. If we tried 5 squared, we're going to get 25, which is larger than 18. So these are our 4 numbers we need to worry about. Okay? And then the last part is to find all the 2-digit numbers whose sum of the digits will give us one of these 4 numbers. Okay, so for 1, well, that's only 10. And remember, 0, 1 doesn't count because that's not a 2-digit number. That's just 1. Okay, 4. Well, we start with the number 1, so that has to be a 3. Then we go to 2. That has to be a 2. Then we go to 3. That has to be a 1. And then we go to 4, and that has to be a 0. Okay, similarly, we can't do 0, 4. And we can't go 5 or anything because it's going to be bigger than 4. Now 9, we start with 1. That gives us 8. 2 gives us 7. 3 gives us 6. All the way up to 9 gives us 0. And then 16. Well, the smallest number we can start at is 7. And that would give us 9. And then 8, 8. And then 9, 7. So the last thing we got to do, just add up all these numbers. How many are there? There's 1, 1, 2, 3, 4. And then 1 to 9, well, that's just 9. And then 3. So add those up. 12, 16, 17. And that's your answer. How many 2-digit numbers have digits whose sum is perfect square? Is 17. Now, on the AMC exam, you'll be given 4 different choices. I don't like showing those choices because I want to make sure all my students knows how to do the problem instead of just guessing the answer. Okay? All right. So make sure you've written that down. I'm pretending I got students here. Any questions? All right. Now, of course, during my actual tutoring sessions, I will ask them to see if they can solve it. Okay, and then I will check the way they did it so I can improve on a faster method. Okay, all right. Next problem. All right, now this one I like because most people are going to do it one way. Okay, but when I was younger, I competed in speed math tournaments, and I'm going to show you a faster way to do this. Okay, so let's look at the problem. The students in Mrs. Reed's English class are reading the same 760-page novel. 3 friends, Alice, Bob, and Chandra, are in class. Alice reads a page in 20 seconds. Bob reads a page in 45 seconds. And Chandra reads a page in 30 seconds. If Bob and Chandra both read the whole book, Bob will spend how many more seconds reading than Chandra? So what most people do is they will take Bob's 45 seconds and multiply it by 760. And then they will take Chandra's 30 seconds, multiply it by 760, and subtract. Yes, you can do it that way. Okay? But I like doing things fast way and easier. What I call easier. Let me show you. The problem says that Bob is 1.5 times Chandra. And that's exactly what they're looking for. How many more seconds? So we don't need to worry about the first all of Chandra. We just need the extra half of Chandra. Okay, and that's key to making this a very simple problem. So the first thing I'm going to do is realize that 30 seconds is a half a minute. So instead of multiplying 760 by 30, I'm going to multiply by half, or rather divide by 2. So 760 divided by 2 is equal to 380 minutes. Okay, because remember, I changed the seconds into minutes. Okay, so Chandra will take 380 minutes. Now remember, Bob is taking just extra half of Chandra. So we divide this by 2, and that gives us our 190 minutes extra. So this is going to be our answer, but we need it in seconds. So we need to multiply the 190 by 60. Now, most people, of course, 9 times 6, 54, and then 6 times 1 is 6, plus 5 is 11. We'll give you 1140. Okay, again, another shortcut is to realize, first off, what does 6 times 19 mean? Okay, it means 6 19s or 19 sixes. So instead of me multiplying 6 times 19, I'm going to multiply 6 by 20 and then subtract 6, because instead of 19 sixes, I'm going to do 20 sixes and then subtract 1 6. Because remember, this is the same thing, okay, as, remember, 6 times 19 is the same thing as 6 times 20 minus 1. And then you distribute, and that gives you 120 minus 6, which is 114. Okay, now I realize for 6 it's no big deal, but what if say that was 13? Okay, 13 times 19 is a little bit harder. So again, 13 times 20, okay, 260, okay, minus 13. Okay, that's easier to do, at least in my opinion. All right, but anyway, this is your answer, 1140 seconds. Okay, all right, let's try another one. And this next one, notice it says problem 17. To me, it should be problem 1 or 2. And the problem is, many of my students will just say, start scribbling down calculations, and then they'll get the answer. Instead of thinking, okay, we got 3 numbers. Okay, you want the sum to be an odd. So what happens? Well, because this is even, sorry, that means one of these must be odd. Oh, look at this. This is all odd. So this must be even. So all we need to worry about is getting a 2. And that happens 1/3 of the time. And that's your answer. So sometimes you just need to think about the problem instead of just diving in and doing calculations. And I must admit, most of my students will just start calculating instead of thinking about the problem. So that's one of the things I like to work on when I help students with the AMC competition, as well as the Kangaroo Math and MathCon. Okay? All right. Let's do the next problem. All right, this is a fun, and it seems to me that some of my students have never played basketball or checkers or chess or anything, because a singles tournament with 6 players. Okay. Each player played every other player only once with no ties. That means every game you have a win and you have a loss. Okay. So all you really need to do, most importantly, is find out how many games were played. So player 1, well, first off, let's find how many players there are. So we got Helen, won 4 games. We got Ines, won 3 games. Janet, won 2. Kendra, won 2. Laura, won 2. And Monica, well, we want to find out. So here we have 6 players. So the first player plays against 5 other players. The second player will play against, well, he plays against 5 other players, but we've already counted that person with this one. So 4 additional players. The third player, 3 additional players, because we've already counted number 3 inside of this one and this one. The fourth one, well, 2 other players. The fifth player, 1 other player. And 6, well, he's already counted in these, so 0. So now we just add up 1 to 5. Okay, 9, 12, 14, 15. All right, now again, this is all fine with just a small number. What if you had, say, 100 players? Okay, the way to do this is to take your first number, add it to the last number, okay, assuming these are all added by ones, okay? So 5 plus 0, okay? And now you multiply by the number of players, well, that's 6, and then you divide by 2, and that will give you 15, okay? So if we had 100 players, okay, so you would have, let's just say, let's say you're adding the numbers from 1 to 100, okay? So 100 plus 1, okay? Here are 100 numbers. You divide by 2. 100 divided by 2 is 50. 50 times 101. And of course, that's the same thing as 50 times 100, which is 5,000 plus 50, so 5,050. Okay? But anyway, so we have a total number of games is 15. Over here, we are told about 7, 9, 11, 13 wins. So Monica must have won 2 times. Okay, so this is how I teach. But first, of course, I ask them to try it on their own. Okay, I give them some time, make sure they understand how to do it. If they take too long, I ask them how they did it, and then I'll try to show them a better way to do the problem. Okay, all right. Hope you enjoyed this video. Okay, thank you very much. Have a nice day. Bye-bye.